everyone, welcome back to another fun science lesson with me. Today we're going to learn about an overview of the periodic table. This is a very important lesson because scientists use the periodic table for many reasons. For discovering its atoms, chemical elements, like or their applications in real life. So today we're going to have a quick overview to see how it was arranged and what applications the elements might have and how it was arranged in a specific order. Firstly, chemical elements are arranged in order of increasing nuclear charge. Remember, chemical elements in the periodic table here, I have two examples right now. They are arranged in the order of increasing nuclear charge. They increase by 1. You see here, we have hydrogen. Its atomic number is 1, and it increased. Helium is 2, lithium is 3, beryllium is 4. And it goes on and on by increasing nuclear charge. And secondly, the periodic table isn't arranged in an order like up, down like this, but they're divided into specific rows. So elements in the same row have the same number of electrons. The same number of electron shells in the atom. They call these rows are like periods. They are like horizontal rows here. These are called periods. So first we're going to learn about the structure. Firstly, its structure. The periodic table, each element are placed in a cell. These are called cells. They're like all these small squares over here. You see, each element are placed in one cell, so they're called elemental cells. And you see here that each cell will provide us information about a chemical element. And the atomic number, the atomic mass, the chemical symbol, and its chemical name. I'm going to give you an example, since this is a little too small here. We have the elemental cell of oxygen. This is what a cell looks like in common images of periodic table, which you can search it online. This cell provides information about the chemical element oxygen. This is the atomic number. That means the atomic number, as I explained, is the number of electrons in the oxygen. This is the chemical symbol. This is its name. And lastly, this number here, however, is the atomic mass. So when we look at the cell, we know that This is the chemical element oxygen. Its symbol is O. Its atomic number is 8 and has an atomic mass of 16. Pretty easy to understand. However, when you learn further about this, you see that some of the periodic table has more detailed information, like this one. It contains complicated, learnings that you will dive deeper when you're older. But now, we're just gonna learn about how the common elemental cells look like. That's a familiar example of elemental cells. Now, firstly, I'm gonna explain to you again about the atomic number. This might be related to the arrangement here. When I say that the periodic table are arranged in increasing nuclear charge, the nuclear charge here is the atomic number. The atomic number is the nuclear charge. And the nuclear charge means the number of electrons. Number of electrons in an atom. And the atomic number, one thing it also determines is the element's position in the periodic table. For example, you see here, hydrogen. It has the atomic number of 1. That means its position is the first element in the periodic table. And it just increases. So it's arranged in a simple order like this. Or another example, you see oxygen, as I said earlier, has the atomic number of 8. So its position is in the 8th place in the periodic table. That is about elemental cells. The second thing about the structure is the periods. So what are periods in the periodic table? Periods are in the order of horizontal rows. When you say horizontal rows, that means here. This is a mini size of the periodic table, and you see these are the periods. This also counts as a period, even though its distance is really far away. But you can imagine there's a line here that connected. There are none of those in the periodic table. And the periods determine the number of electron shells of elements. Number of electron shells. For example, the element, and here, let me show you a closer look. The periodic table has 7 periods marked from 1 to 7. For example, hydrogen is marked as period 1. That means hydrogen has 1 electron shell. Oh, I want to introduce you guys to my new assistant. Apologize. So we will call simply, there are 7 periods, right? The first 3 periods are kind of short. The first period consists 2 elements. The second period consists about 9 elements. 8 elements, I mean. So it's the same as the third period. So we call them the small periods. One, 2, and 3. The rest of them, period 4, 5, 6, 7, is these long. So we call them large periods. That's another kind of structure in the period table you see here. One last thing. Thank you for your kind generosity. It would be fun for a little cartoon over here you want to watch. The last kind of structure I want to show you today is groups. It's a little complicated that the periodic table not only arranged in horizontal rows, but the mean in vertical rows also have meanings. They're really meaningful, not only horizontal rows. In the vertical, all these vertical rows are called groups. You see, the periodic table consists of 8 groups of A. They're marked as 8 groups of A. From 1A to 8A. This is 1 if you didn't notice, because if you have learned, they're actually Roman numbers. But scientists use them in the periodic table to define the names of the groups. So the periodic table has 8 groups of A from 1A to 8A, and 8 groups of B. From 1B to 8B. And the number of groups also determine one other thing. As I said earlier, the periods determine the number of electron shells of an element. Like elements in the same period has the same number of electron shells. However, the groups determine the number of electrons in their outermost shell. For example, here, I'll take lithium. Lithium is in group A, group 1A over here. And its period is period 2. That means lithium has 2 electron shells, and in the outermost shell, which is the second shell, it has 1 electron. And you see the groups are 8 groups of A and 8 groups of B. Well, I apologize that not all groups means that not all groups determines the number of electron shells. Number of electron in the outermost shell. It only works for groups of A. And based on the groups, we have some basic information. Group 1A are typical metals. So they have names for themselves too. They are called alkali metals. Or group 2A. They are alkali earth metals. Oh, noted that group 1A are all typical metals or alkali metals except H, which I will explain to you later. Next is group 7A. They're halogens. Or group 8A. They are noble gases. These are some basic information about the groups. Now I will move back to the part why hydrogen isn't alkali metal. Why? Well, you see here, the periodic table consists of 3 kinds of elements: metals, nonmetals, and noble gases. And in the periodic table here, hydrogen is marked as a nonmetal. But hydrogen has similar properties with the elements in group 1A. So that's why it is placed on the top of that group. But to be placed on the top doesn't mean that it's an alkali metal. It just has similar properties with the other elements in that group. Lastly, to the last second part of it, let me find my eraser. Here it is. The second part for learn today is about positions. We're gonna learn about the positions of metals, nonmetals, and noble gases in the periodic table. Firstly, metals. While scientists have discovered 118 chemical elements, more than 90 elements are metals. That's a lot, right? It's the most popular kind of metal in the periodic table. Since you can see here that it resembles in yellow. Or in this model, it is resembled in blue. Yeah. And among the metals that are in the chemical elements, they include most elements in group 1A, 2A, 3A, and also some few elements in 4A, 5A, and 6A. This careful observation you see here. Group 1A have most of the elements, and group 2A, 3A, 4, 5, 6, they all have some of the elements that are metal. And they have many applications in daily life. I'm going to give you an example. Some examples, actually. Oh, I forgot. They also include some elements in group 1 from group 1B to 8B, including the Lithuanian and the acidity. Sorry about my pronunciation. And some applications in real life. There are lots of familiar applications that you can see in daily life. For example, aluminium. Aluminium is a chemical element. It's a metal. And do you know what it's used for? It's used for food wrappers. How about copper? It's a more similar term. I mean, here, copper. What's copper used for? Try to think. Copper is used for wire cords. The wire cords that you usually see in the your electricity devices, which is really familiar. Another example. You see my earring here? What is it made of? Or other kinds of jewelry that you saw at a diamond store. What is it made of? It can be made of silver or maybe gold. I've given you 3 familiar examples of the chemical elements applications in daily life. So, can you find more applications of these metals? Well, try to look around more and put some careful observation in your study. Okay, now you move on to the second type. The second type of elements are nonmetals. Among the 118 chemical elements, less than 20 chemical elements are nonmetals. Here, you can see that they resembled in pink. The pink color are nonmetals. So, in each group, there are nonmetals too. I have a few of the information here that I have noted down carefully. Nonmetals under normal conditions, they can exist in solid, liquid, or gas form. And nonmetals in the periodic table, they stood out in most elements group 1A, 2A. Not that. Most elements in group 7A, 6A, and 5A. And some other elements are nonmetals in group 4A and 3A. And there are one more nonmetal, is hydrogen. It stood out perfectly in group 1A. Hydrogen. So nonmetals, remember that there are less than 20 nonmetals. They include elements in the group 7A, 6A, 5A, 4A, and 3A. Because hydrogen in first A. And under normal conditions, they exist in solid, liquid, and gas. We quickly move on to the last type. Noble gases. Okay, I'll quickly. There are 7 elements that are noble gases. And you can see here, they are the yellow color, which means that they belong in the group 8A. Noble gases only have 7 elements. Their atoms have stable outer electron shells, so that means they're difficult to undergo chemical changes. For example, helium is a noble gas and is used to make balloons. Used in balloons, you see. So you always wondered why balloons can float up, because there's helium in them. Another example is neon. Neon, right? Here. Neon can be used in LED lights. So for real applications, neon can be used in LED lights. And that's some short information about the noble gases, since they're really less. But anyway, we have somehow reached the end of our lesson today. I'm pretty sure you have learned many things that may be complicated, but if you study it more carefully and discover more, you'll be able to understand more. And then you expose it to different branches, medicine, architecture, and many other things. Well, but I hope you enjoyed my lesson today. And tell me what you have learned in the comments. Thank you. See you again. Bye-bye.